Okay, now in this video I'm going to talk about the gradient of a straight line and tangents to curves. And this is something you've probably already done in school, and in which case I'd say you can skip this video. If you know how to find the gradient of a straight line and the equation of a straight line, given say two coordinates, if you think you already know that, then you can skip this and go to the next video, because this is one to just recap what you may have already done. Now we say that the gradient of a straight line is always constant, and the gradient, or it's also called the slope of a straight line, usually denoted by the letter m. We say the gradient is equal to the change in y divided by the change in x. Change in x. And you might have also seen this written as delta y divided by delta x. The delta just means a change, so it's the change in y divided by the change in x. So let's just say we are given a straight line with a couple of points. Let's say we have x and y and a line that goes like this. Let's say at this point, this point has coordinates 1, let's say 4, and another point with coordinate, let's say x is equal to 3 and y is equal to 8. Now what's the gradient of this line? The gradient of this line would be the change in y. So the y changes from 4 to 8. So if I take this change here, y changes from 4 to 8, so that's 8 minus 4. So that's 8 minus 4 divided by the change in x. So the value of x changes from 1 to 3. So 3 minus 1, I get 2. So I get 4 divided by 2, and in this case, the gradient of this line is 2. And we say the gradient of a straight line never changes, which means I could take the change in y divided by the change in x between any 2 points. It doesn't have to be these 2 points. Let's say if I know the coordinate at that point, when let's say x is equal to 2, if y was equal to 6, then I could take the difference between these 2 points. The gradient between these 2 points will be the same as the gradient between any other 2 points. And in general, we say if I know 2 points, let's say I call this point 2 and this is point 1. And let's say the coordinates of point 1 are x1, y1. Let's say the point 2 has coordinates x2, y2. Then we say the gradient is equal to the change in y, which in this case is y2 minus y1. So that coordinate is y2, this coordinate is y1, this position is y1, so the difference is y2 minus y1 divided by the change in x. X changes from x1 to x2, so that would be x2 minus x1. Now it does not matter which point you take as your point 1 and point 2, but it is important that if I take y2 minus y1, then I have to take x2 minus x1. Or to put it another way, if I take the y coordinate of point 1 minus the y coordinate of point 2 as my numerator, I have to take the x coordinate of point 1 minus the x coordinate of point 2. Okay, now in this case, you've seen how to find the gradient of a straight line. And if the line goes from bottom left to top right, then we say the line has a positive gradient. If the line goes this way, say from top left to bottom right, then we say the gradient of that line is negative. Well, actually, let's just plot a couple of axes here. I'll say that's my x and y axis. And let's assume this has x coordinate 1, let's say 10. The coordinate of that point is 1, 10. And let's say I have another point with coordinate maybe 5, 2. So what's the gradient of this line? So first thing to do is to pick your points 1 and 2. Let's say let that be my point 1 and that's my point 2. So the gradient of this line is equal to y2 minus y1. So that's 10 minus 2 divided by x2 minus x1. That is 1 minus 5. So 10 minus 2 is equal to 8. 1 minus 5 is minus 4. And the gradient of this line is equal to minus 2. And also, if I have several lines, I can also say which line would have a higher gradient than the other. I can compare one or more lines. So let's say I have a line going through the origin like that. And let's say assume that the gradient of this line is equal to 1. If I had a steeper line, then I can definitely say that, say if I know they're going through the same point, if the line is steeper, then I can say this gradient will definitely be more than 1. The gradient of this line will always be more than the gradient of this line. And a line less steeper will always have a gradient of less than what the gradient of this is. Or to put it another, if I call this the gradient m1, then this gradient is less than m1, this gradient is more than m1. And the same also applies to negative gradients. The steeper the line, the higher the value of the gradient. Okay, now from this one, now we've seen that for a straight line the gradient is always equal, and the gradient of a straight line is quite easy to work out. If I know 2 points, or if I know the equation of the line, then I can work out the coordinates of 2 arbitrary points and then work out the gradient. Now how about the gradient of a curve? Let's assume I have a curve that looks something like that. Whereas the gradient of a straight line is always a constant, the gradient of a curve is always changing. So if I take the gradient between this point and this point, the gradient here will be different to the gradient here, and every point as I move along the curve, the gradient keeps on changing. And to find the gradient, let's assume I want to find the gradient at this point. We draw a tangent line to that curve at that point, and we call this the tangent line. And a tangent to a curve is a straight line that touches only one point on a curve. So this line touches this curve only at that point. Now the gradient of the curve at this point is the same as the gradient of this tangent. So let's assume the gradient of this line is m1. Then the gradient of this curve at this particular point is also equal to m1. Similarly, if I want to work out the gradient at this point, then the gradient, I had to draw a tangent at that point. The gradient of this straight line at that is equal, let's assume this is equal to m2, then the gradient of the curve at this particular point is also equal to m2. As I move along the curve, I could say the gradient at this point is very, very steep. If I draw the tangent line is very steep. So I can say that the gradient at this point must be higher than the gradient at this point. And similarly, I can say that the gradient at this point will be negative because I have a negative sloping tangent line, and the tangent at this point is steeper than this tangent, so I could say that this has a higher gradient than this point here, or at least a higher value, but when you think of the negative scale, this is lower than that. And also just to mention that the gradient of a horizontal line, if I have my x and y axis, if I have a horizontal line, then we say the gradient of that line is equal to 0. Because if you imagine taking 2 points, maybe the first point is 1, 5, and let's say the second point, the x coordinate is arbitrary, so let's say 3. Now there is no change in y between that point to that point if it's a horizontal line, so the y coordinate will also be equal to 3. And we know that for a straight line, the gradient is given by y2 minus y1 divided by x2 minus x1. So the gradient of this line will be 5 minus 5 divided by 3 minus 1, which will be equal to 0 divided by 2, and that's equal to 0. So we say that the gradient of a horizontal line is equal to 0.